Ladies and gentlemen, good morning and welcome to another session of Physical Sciences Paper 2 Memo discussion. And this will be presented by Mr. Sefo. Mr. Sefo is a subject advisor in Leisurely Putswa, and he will be coordinating this, and I will only be assisting in terms of the logistics, as well as now ensuring that we have a recording and a streaming live on our YouTube channel. So without wasting any time, it is exactly 8:31, I believe, that SFO. We can be in a position to start to save now the colleagues time. Colleagues, with that being said, let's just remember we should now keep our mics off at all times, as well as the videos, they're off, and we will ask questions immediately after the presenter is done with the whole question for inputs and comments thereof. Ladies and gentlemen, welcome once more, and that is it. For the platform is yours. Thank you very much.
Thank you, Ntate Nambani. Colleagues, good morning. I'm not sure whether I'm audible enough. Am I audible from your side, Ntate Nambani?
Yes,
Colleagues,
yes, and that is it. For you are audible. Thank you.
Okay. All right. No, thank you. Colleagues, good morning once more. Today we are looking at the physical science paper 2 that was written yesterday, and my task is just to get you through the marking guideline and make amendments and suggestions there and then. And without waste of time, colleagues, I should believe that if you have marked or you have pre-marked the 5 scripts as has been asked for, you are quite aware that the multiple choice questions will stay like that. There is no amendment on multiple choice unless there is anything that one will want to comment on multiple choice. But the multiple choice stays as it is. Then we go to question 2. Question 2 reads thus: the letters A to E in the table below represent 6 organic compounds. There are organic compounds A up to E then. Question 2.1 says, learners were asked to write down the letter or the letters representing the following. 2.1.1, it was a compound with the general formula CnH2n-2, and then the correct answer there is B. 2.1.2, the letter that represents the ketone, the correct answer is D. 2.1.3, a compound that can be used as a fuel, the correct answer there is A or B. It's either Elena will write A or B. Those are the acceptable one for 1 mark. 2.1.4, an unsaturated hydrocarbon can only be letter B. And then 2.2, for compound E, write down the name of the functional group. The question was looking for there was the name of the functional group, and then the name of the functional group is a carboxyl. That goes for 2 marks. And we are looking at 2.2.2, the structural formula of its functional isomer. Because it is a butanoic acid, it is a carboxylic acid. Functional isomer must be an ester. This is option number 1. And what we are looking at is that there must be 4 carbon atoms in that ester, but the functional group must be the functional group of an ester. It means one thing that you must be on the lookout for is whether the functional group is correct. Then you can allocate a mark for that functional group if it is correct. And then the other mark will be for the whole structure if it is correct with all the bonds that are being indicated there. This is one option there. And then the other option will be this other option here. Same thing. And then the other option will be this option. And therefore, what is the marking criteria? Like I've alluded to, the whole structure must be correct. Therefore, that learner will get 2 out of 2. It means whole structure being correct will mean that the functional group is correct, and then everything is correct. 4 carbon atoms, all carbon atoms have formed 4 bonds, all hydrogen atoms are there. Therefore, that will, if only the functional group is correct, then that learner will get 1 out of 2. And then 231, question 2.3, write down the IUPAC name. We are looking for the IUPAC name, 231 of compound C. And then when we look at compound C, that is a haloalkane. And therefore, what is the correct name there? It is a 3,5 dichloro, 4-methyl, and then octane. Therefore, colleagues must be on the lookout for the marking criteria then. 1, if you see an octane there, then you must give a mark. It shows that the longest carbon chain contains 8 carbon atoms. The other mark will be on a 4-methyl, therefore that is 1 mark. Remember that 4-methyl must go with a hyphen between the number and the name. And then the other mark, the last mark must be on a 3.5 dichloro, and therefore that will give you 3 marks. And then question 2.3.2, we are looking for the IUPAC name of compound D. And when you check that compound D, it is a propanon. It means 2 or nothing, propanon or propan 2 on. And then 2.4, we are looking for, the question was looking for the IUPAC name of the functional isomer of compound D. And then the functional isomer of that compound D will be a propanal. And therefore, 2.5, the question was looking for the structural formula of the chain isomer of compound A. Compound A is a butane, then its chain isomer will be this compound. And therefore, remember the marking criteria. If you have got a 1-methyl substituent there, therefore it's 1 mark. Therefore, if the whole structure is correct, then the other mark will go there for the whole structure being correct. It means together with the methyl substituent. And therefore, also note that if a learner has written a condensed structural formula or a semi-structural formula, then you will give 1 out of what? 1 out of 2. But if the molecular formula is written, then it will be 0 out of what? It will be 0 out of 2. Then question 2.5.2, they were asked to draw the structural formula of compound E. And therefore, here is the structural formula of compound E. Compound E is a butanoic acid. It means here is the correct structural formula. What we are looking for then, we are looking for the correct functional group, 1 mark, and then the whole structure must be correct so that the learner can be awarded full 2 marks. But if only functional group is correct and then the whole of the structure is incorrect, then that learner will get 1 out of what? 1 out of 2. And then that is that in terms of question 2, colleagues. I'm not sure if there are any inputs or clarity seeking question. I will open this. I can see some hands. You will bear with me, colleagues. I can see a hand, but I cannot really recognize who's this because it is written here on me, view all. Therefore, I don't know. Let me just invite the questions. Just unmute yourself and then tell me who you are and then what are you looking for? Or what is the input?
Thank you, Mr. Sifo. This is Mr. November. I have a question with regard to question 1.1 on multiple choice.
Yes.
Yeah, on 1.1, that option D, I think the correct answer is supposed to be 2 methyl, 2 methyl propan 2-ol. Maybe there's 2 that is missing there for that answer to be D on the question paper. If you want to make the tertiary alcohol, it's supposed to be 2 methyl propan 2-ol in order for that D to be correct. Then another question is on.
Can we address this one first, Mr. November?
Okay.
Before you go on. If you make a primary, a secondary, a tertiary alcohol, whether you have mentioned 2 methyl or not, but your branch will always be on carbon atom number 2. Therefore, whether you say 2 methyl or you don't say 2 methyl, you say methyl propan 2-ol. But it means for it to have got a branch, the branch will always be on carbon atom number 2. I hope that one is clear.
Oh, okay.
All right. Can we address the other one?
Question 2.3.2, compound D.
2.3.2.
2.3.2. Yes. The answer there, I see on the memo you have propanon. Isn't supposed to be 2-propanon, where the learner specify the name of the functional group of carbon number 2. So there are 2 options there. It's propanon without the name of the functional group. The first option, I think maybe that first option is supposed to be 2-propanon. There is no.
What you are saying is the second option, that is propan 2-on. Therefore, we'll accept if a learner has written 2-propanon. Here in 2.3.2, it is the same thing that I have explained in terms of question 1, that whenever you have got only 3 carbon atoms there in propanon, therefore your carbonyl group can only be on carbon atom number 2. It cannot be on carbon atom number 1. That is why the memo accepts both propanon and propan 2-on, and therefore instead, in terms of propan 2-on, a learner will be credited if he has written 2-propanon. I think the memo caters for both options.
Okay, no, thank you.
Thank you. Besides Mr. November, colleagues, if you are done, you can just lower your hand so that we know that your issues have been addressed and catered for. Any other question, colleagues? I don't see any other hand unless there is something. Therefore, it means we can continue. Right, and then we are going to question 3, colleagues. Question 3, it's on physical properties of organic compounds. And the question starts with 3.1. The vapor pressure of 2 organic compounds at a specific temperature are compared. We have got compound A as a butane and then compound B as a methyl propane. And their molar mass is given in grams per mole, 58 each. And then the first question, that is 3.1.1, says learners were asked to define the vapor pressure. And the vapor pressure is defined as the pressure exerted by vapor at equilibrium with its liquid in a closed system. That is 2 marks. But colleagues, let us be on the lookout for the marking criteria. If any of the underlined key phrases in the correct context, the concept of the correct context there is omitted, then you must deduct 1 mark. It means that learner can get 1 out of 2. But under the conditions that he has omitted any of the underlined keywords, but whatever that is said there must be in the correct context, then that learner will get 1 out of 2. But in essence, for that learner to get 2 out of 2, anything that is underlined there must be there. And 312, which one of the 2 compounds will have the highest vapor pressure at a given temperature? Write down only A or B. And then that will be what? The correct answer will be B for 1 mark. And then 313, give a reason for that. The reason for that, it's either a learner will refer towards compound B or refer towards if a learner is referring to compound AB, therefore that learner must be referring towards a smaller surface area of compound B. But there is something that is missing there. He might also be referring to B being more branched than what? Than A. Smaller surface area or more branched. B being more branched, then that will go for 1 mark. Therefore, because it has got a smaller surface area or it is more branched, therefore it has got weaker intermolecular forces. And therefore, the last mark that will be there will be less energy needed to break intermolecular forces, not to break up the bonds. Therefore, that will be 1, 2, and 3. But some learners will go towards explaining it in terms of what? In terms of A. A will have got larger surface area or it is not branched. And therefore, because of that, it has got strong intermolecular forces or more intermolecular forces. And therefore, more energy is needed to break the intermolecular forces of what? Of compound A. Therefore, that will go for 3 marks. And 314, give one reason why the above comparison can be considered a fair comparison. Therefore, colleagues, look them. A learner might be saying 1 independent variable, then we give what? We give 1 mark. Or a learner can be saying same homologous series and are chain isomers. Same homologous series and are chain isomers, then we give 1 mark. Same molecular mass and are chain isomers, then we will also give what? Then we will also give 1 mark. And then question 3.3 or 3.2, the compounds propan-1-ol and propanol are compared. Therefore, it is 3.2 has got nothing to do with the table that is given there. It has got something to do with a propan-1-ol and a propanol. Which compound will have got the highest boiling point, and then fully explain the answer. The one which will have got the highest boiling point will be a propan-1-ol. It means give 1 mark for propan-1-ol. And therefore, in terms of the explanation is that the propan-1-ol has got the hydrogen bonds in addition to dipole and London forces. And then propanol has got dipole forces in addition to London forces. I guess, colleagues, we can just remove the underline or look there that dipole forces are in brackets. It means even if a learner cannot say propanol has got hydrogen bond in addition to dipole, as long as he has made mention that propan-1-ol has got the hydrogen bond and the propanol has got the dipole, then we give 1 mark. And therefore, the intermolecular forces of propan-1-ol are stronger than the intermolecular forces of propanol. Therefore, that will be another what? That will be another another mark. And therefore, that question goes for 4 marks. When I look at here, it's like there is some mark which is left there. Can we check there? It means for saying propanol, then we allocate a mark. Then for propan 1 all having the hydrogen bonds, therefore we give 1 mark there. Therefore, it means there is a mark that is a tick that is left there. Can you put that tick? And then between the molecules of propan, there are dipole forces. That will be the 3rd tick. This is the 3rd tick. And then comparing the strength of intermolecular forces, then that will be another tick. Oh, but something is coming into my mind now. Can we leave this tick as they are and then add another statement there? And then the statement, the other statement, the last bulletin that will be there will be more energy is needed to overcome the strong hydrogen bonds in propan 1 all. More energy will be needed to overcome the stronger intermolecular forces or hydrogen bonds in propan what? In propan 1 all. And therefore that is your 3.2. Then your 3.3, the table below shows the results of an investigation regarding the melting points of organic molecules. And colleagues, let me make a disclaimer. 3.3 is talking about the melting point, but when you check the table there, the table is talking about the boiling point. Therefore, be on the lookout that we are aware that they are not talking the same. The statement is not talking to the table, that one, but we will correct it as we move forward. Right, 3.3.1, write down the independent variable for this investigation. Therefore, it means the independent variable then will be what? Will be the branching. Will be branching. And therefore, 332, explain the trend in the boiling point of the above what? Of the above core compounds. Therefore, from A to C, and then also be on the lookout for 3.3.2. You will accept if the learner has correctly compared only compound B, N, and C. That is one thing that you must be aware, because now some learners might get confused between 2.2 dimethylbutane and 2.3 dimethylbutane. And then others will only talk about compound B, N, and C. Therefore, please accept if a learner has compared only B and C. Therefore, what is that 3.3.2? We are explaining the trend in the boiling points of the above investigation. Therefore, from A to C, we have got less branching, or we have got the greater surface what? The greater surface area. And therefore, the stronger or more intermolecular forces, or the learner cannot be referring to the intermolecular forces, it can be specific about the London forces. Therefore, more energy needed to break the intermolecular forces or the London forces. And therefore, that will be your 3 marks. And then the total for that question will be 15 marks. I'm not sure, colleagues, any inputs, clarity seeking question? I've got someone from Killing Matsiripe.
All right, that is for Dumelang, colleagues. This is about question 3.3.1. And then what we are seeing there is that the branching, maybe we may need to consider other options like the surface area or the chain length. Why do I say that? Only A and B has got the same chain length, but immediately when you introduce C, the chain length changes. So I think 332 came with that thinking from 331. So I don't know, I'd like to propose maybe can we adopt an issue of the surface area and chain lengthener for 331.
Noted in that the Marisa Smith. Ms. Smith.
Hello, it's Joy. Hi.
Yes, ma'am.
I'm also asking about chain length in more than one place. At 3.1.3 and also at 3.3.
Ma'am, your line is not that you are breaking along the way. I cannot hear what your input.
Okay. I will try again.
Yes.
At question 3.1.3 and again at question 3.3.2, if the learner has answered the question in terms of the length of the chain, can we award them the marks if their argument is correct?
All right, noted. Any other question? Can you lower your hand?
Sure, thank you.
Thank you. I can see there is Chabalala.
Good day, Bob. I was asking that 3.1.3 in that last bullet. Is it to break the intermolecular forces or to overcome?
The learner can talk about breaking or overcoming, then we'll still allocate marks.
Okay, thank you.
Thank you. Right. Colleagues, let me go to the proposal there, and in terms of the chain length and branching. And colleagues, I will say that during our teaching, we need to be specific when we talk of the chain length and branching. The chain length will be 1 carbon atom, 2 carbon atom, 3 carbon atom in the straight chain. That will mean the chain length, and the molar mass will also not be the same. But the minute you talk of branching, you are talking about isomerism. And in the question paper, they appear as chain length, they appear as isomerism. But for the sake of progress and moving forward, can we accept that? But I don't think that going forward, that will be accepted. That is something that we also need to go back and correct during our teaching, that chain length and branching cannot talk the same thing. Thank you, colleagues. Can we move if there is nothing that is, I think everything is clear. Right. Let's move to question number 4. Question number 4 is all about.
I think the initial thought of moving that mark to hydrogen bonding was a good one. Why do I say that? It's because the issue, the energy requirement is in the OR part. So I don't know if we then do that, it means the energy issue is no longer the OR part, it's part of the solution. So I don't know whether perhaps do you want to revert to giving that hydrogen bond a mark, or do you want to remove the OR part? Thank you.
We are on 3.2. 3.2.
I create the first mark was for choosing propan 1 all, and then originally the memo was saying for mentioning the types of intermolecular force on each, and then the third mark went to the strength, and then that was 3 marks. And then now when later it says OR, the energy requirement. And the energy requirement being the or part makes it not to be part of the 4 marks. It makes it like it's the 5th mark or something.
No, it is still 4 marks. Let's check the marks. It's just that on my screen, the whole question does not appear on the same page. Look for the marks in that the take so 1 mark is here. Where on saying propan 1 all. 1 mark will be on correct identification of the type of intermolecular forces on both. And then the other mark is on intermolecular forces, on the strength of intermolecular forces. And right, more energy, strength of intermolecular forces, or more energy needed to overcome the intermolecular forces there. Okay, no, I see what you are saying. Therefore, I see what you are saying. I see what you are saying. And then, colleagues, let us now agree that on bulletin number 2, we are going to allocate 2 marks. 1 mark for correct identification of hydrogen bonding in propan 1 all, and then the other mark for correct identification of dipole-dipole forces in propanon. And therefore that will go for 3.2. Thank you, Ndade Tekiso. Mr. Libenya.
Mr. Sifo, how are you?
I'm good, and you, Sam?
Thank you so much, my brother. It's regarding 331.
331, yes.
Yes. I understand fully that branching and chain length, 2 different things. But if a learner decides to write surface area, will that be correct?
Yeah, let's give him the mark.
Thank you so much, sir.
Thank you. Lower your hand, Mr. Libenya. Thank you. Thank you. Lower your hand, Mr. Libenya, for the sake of progress. Thank you. Colleagues, let's move to question number 4. Let's move to question number 4. Question number 4 is on organic reactions. The flow diagram below shows the preparation of different organic compounds from CH3, CH2, CH3. Letters X, Y, Z represent the organic reactions. And then 411, write down the type of reaction represented by the reaction X. That reaction X is elimination reaction, or it is dehydrohalogenation for 1 mark. 412, reaction Y, it is a substitution reaction or hydrolysis for also 1 mark. 413, it is Z, it is an elimination or a dehydration also for 1 mark. Then question 4.2, reaction X takes place in the presence of a strong base. Then write down the IUPAC name of compound what? Of compound A. Therefore, that compound A must be a 2-bromopropane, 1 mark for 2-bromo, and then 1 mark for a propane. That will give the learner 2 marks. Then 422, learners were required to write a balanced equation for the reaction X using structural formula. And therefore, what is the allocation of marks? 1 mark for the structural formula of what? For this structural formula of 2-bromo propane, 1 mark for the structural formula of a propene, 1 mark for sodium bromide, and then 1 mark for water. And therefore, let's look at the marking criteria and the notes there. You will ignore if a learner has used double arrows, it shows a reversible reaction there, then that learner will also will still be allocated full mark, credited full marks. Any additional reactants or product, then that learner will get 3 out of 4. And then you will also accept any coefficients that are multiples of what is correct here. And then if a learner has written a condensed or a semi-structural formula, then you will subtract 2 marks. Then that learner will get 2 out of 4. And then if a molecular formula is also given, it will be treated the same way as the condensed structural formula. That will be 2 out of what? 2 out of 4. And then that will give us what? That will give us 4 marks for that particular question 4.2.2. And then 4.2.3, we are looking for the IUPAC name of the alkene that is there. And therefore the IUPAC name, it is a propene, a prop 1 in. Please remove that E there from the memo. Cancel that E there. It is a prop 1 in, or it is a propene. Then cancel that E there. And then 4.3, two differences in the reaction conditions between X and Y. During reaction X, being an elimination reaction, you need concentrated strong base and heat. Concentrated strong base and heat, 1 mark. During reaction Y, you need a diluted strong base and mild heat. Then you get what? Then you get another mark. Then that will go for 2 marks. And then question 4.4, compound B is a secondary alcohol. Then define the concept secondary alcohol, or the term secondary alcohol. In the secondary alcohol, we all know that the carbon atom bonded to the hydroxyl group or bonded to the functional group is bonded to 2 other carbon atoms. Therefore, that is 2 or nothing. Or the functional group is bonded to 2 other carbon what? To 2 other carbon atom. The carbon atom where the functional group is bonded towards 2 other carbon atoms, and then that will be 2 marks, and then the total for that question is 15 marks. Can we invite clarity seeking question and inputs colleagues if there are any? Once, twice, I think that we are doing quite good. And I also have got a sense that this paper was much easier than one would have expected. Colleagues, let's go towards question 5. In question 5, glucose is metabolized in the human body through the simplified equation, the C5H12O6 plus 6O2. Then it forms CO6CO2 plus H2O. That is a combustion reaction. The graph below shows the energy changes for the above reaction. There is a energy profile graph there. And then question 5.1.1, is this reaction endothermic or exothermic? Then give a reason for the answer. The reaction is exothermic. For saying exothermic, that is 1 mark. And energy of the product is less than that of the reactant, or energy is given off, or delta H is less than 0, then that will go for 1 mark. 1 mark for exothermic, 1 mark for the resin. 5.1.2, express the following in terms of the energy values A, B, C shown in the graph. The energy of the activated complex will be A for 1 mark. The activation energy for the reverse reaction will be A minus C. The heat of the reaction, or delta H for the forward reaction, will be C minus B. And then just take note, colleagues, when marking that B and C is 2 marks. And then that 2 marks is given when everything is correct, not saying 1 for A, 1 for C. That 2 or nothing is A minus C or C minus B. And question 5.2, it reads thus: in an investigation of the rate of reaction, an excess 200 centimeter cubed solution of hydrochloric acid of a concentration of 0.5 mole per cubic decimeter react with zinc powder at standard temperature and pressure. And the following spontaneous reaction takes place. There is zinc reacting with hydrochloric acid to form zinc chloride plus hydrogen gas. And the volume of hydrogen gas produced is measured at regular time interval, and the following graph is drawn. That is the graph of the volume of hydrogen gas produced against the time E interval. And then question 5.2.1, define the term concentration. Concentration is defined as the amount of a substance per volume of water or volume of solution. And then that will give us 2 marks. And then 5.2.2, write down the limiting reagent for the above reaction. Therefore, for 1 mark, it is zinc. Either the learner will give you the correct name or the symbol, then that will be acceptable. And then 5.2.3, the learners were required to calculate the mass of zinc that is being used. But remember, zinc is a limiting reagent. They can only calculate that using the volume of hydrogen gas that is being produced there. Because it is at standard temperature and pressure, 1 mark goes for the formula. Number of moles of hydrogen is the volume over the molar volume. That will be 1 mark. 1 mark will go for the correct substitution. Take note of the conversion of conversion from centimeter cubed to decimeter cubed, and then 1 mark goes for the whole of that substitution. No mark on the number of moles, but 1 mark will be on the molar ratio, that the number of moles of what? From the balanced equation, number of moles of zinc is equal to the number of moles of hydrogen. Therefore, it means now the number of moles of zinc will be 0.0185. It means no mark here, but the mark will be on the molar ratio. And therefore, the mass is number of moles multiplied by the molar mass. Therefore, the other mark is on the substitution there, and then the final answer. And then just take note, colleagues, that there is a range there in terms of the answer. Accept anything between 2 grams to from 1.3 grams towards 2 grams. That is your question 5.2.3. 5.2.4, the same mass of zinc granules is used instead of the zinc powder. They have just changed the state of division there. And then 5.2.4a, how will this affect the rate of reaction? Choose from increase, decrease, or stays the same. Because we are now using granules, therefore it means the rate will decrease. 1 mark for saying decrease. And B, use the collision theory to explain the answer to question 5.2.4. Therefore, decrease in surface area, 1 mark. Fewer particles with correct orientation, that will be 1 mark. And then fewer effective collisions per unit of time, or fewer, the frequency of collision of effective collisions decreases, then that will be 1 mark. That will go for 3 marks. And then 5.2.5, a suitable catalyst is added to the reaction mixture. Redraw the graph above in your answer book and label the given curve A. It means the learner must start by redrawing and label the graph as graph A or curve A. And on the same set of axes, sketch the curve that will be obtained if a catalyst is added there. And then label that graph A, graph B. Take note, colleagues, that if both graphs are not labeled, therefore you cannot distinguish which one is A or B, then that learner will get 0 out of 2. I hope that one is fine. And then these 2 marks, colleagues, can you make the notes on your side there? We are going to split these 2 marks. 1 mark will go when the gradient of B is steeper than the gradient of A. Then we give 1 mark, showing that the reaction rate of B is faster than the reaction rate of A. It means this graph, the dotted one must move before above what? Above this one, steeper gradient, then will give 1 mark. Then the other mark will give if a learner has noticed that at the end of the day, they will produce the same amount or same volume of what? Of hydrogen gas. It means if they end at the same point, then we'll allocate another mark. And then that question will go for 21 what? Will go for 21 marks. That is question 5. Any input? Mefori, are you good? Mefori?
Morning, Mr. Sifu. Yes, can you hear me?
Yes, I can.
I'm fine. How are you?
I'm good.
Okay, good. Business. Question 5.2.1. The learner makes a funny definition that is correct. He says the concentration of the amount of solute to the volume of the solvent. Can I accept?
5.2 point. The concentration of the amount of solute.
The concentration of the amount of solute to the volume of the solvent instead of water.
But it's not talking about the amount, it's referring to the concentration.
He says, sorry, he says it, he says concentration is the amount of solute to the volume of the solvent.
Yeah, let's give 2 marks, Alta. Right, and Tadele Benya?
Khabani yaka e ho 5.1.2.
5.1.2. 5.1.2, yes.
Yeah, I just need clarity. Like, for example, let's take B. I understand on the memo what it is being written, but is it A to C or is it A minus C?
Is A minus C.
Okay, so in other words, also if learner has written A and C, that would be wrong.
That will be wrong.
Okay, thanks, Intent.
Thank you, Pap. I see no hand, Mr. Benya. Just lower yours, please. Right, and then colleagues, let's move to question number 6. Question number 6. Hydrogen iodide, HI, is allowed to decompose in a 5 decimeter cubed closed container at a temperature of 425 degrees Celsius, according to the balanced chemical equation given below. When the reaction reaches equilibrium at 425 degrees Celsius, it is found that 0.02 mole of hydrogen gas is present in the container. And the equilibrium constant for this reaction is 425 degrees Celsius. At 425 degrees Celsius is 0.016. And question 6.1, it was the definition of a closed system. A closed system, it is the system that is isolated from its surrounding, 2 marks, or it is a system where substances cannot leave or escape the container. That will also get 2 marks. And then 6.2, calculate the initial number of moles of HI in the container for 8 marks. Therefore, we have got 2 options there. Option number 1, colleagues, be on the lookout for the mark allocation. Question, first mark will be given when the change in the number of moles of hydrogen equals to the equilibrium number of moles of hydrogen, and then they are equal to 0.02. This is the first mark. the change in the number of moles of hydrogen gas equals to equilibrium number of moles of hydrogen gas, and they are both equals to 0.02. This is A, this is point A, then you'll allocate the mark there. Second mark will be using the ratio of hydrogen iodide to hydrogen and iodine, and then the ratio must be 2:1:1. This is the ratio. Therefore, it means the ratio will now be saying that because they are occurring in that ratio of 2:1:1, therefore iodine will also have the change in number of moles of 0.02, and then hydrogen iodide will be 0.04. It means for the whole of this ratio, then you will give another mark. That will be your second mark. Your third mark, that will be the equilibrium moles of iodine equals to the change in moles of iodine. The equilibrium number of moles of iodine. The equilibrium number of moles of iodine is equal to the change in number of moles of iodine. Then that learner will get another mark. That will be your third mark. And then your fourth mark, divide 0.02 by 5 and multiplying 0.0316 by 5. It means if a learner to go here, we are looking at here and there. It means that learner must have divided this by 5 and then divided this and then multiply this by 5 to get to 0.15158. It means this must be 0.004, 0.004, and then this must give you 0.158, and then that will be what? That will be the marks there. And then E, we are now going towards the correct expression. Just be on the lookout that on the table there are only 5 marks, 1, 2, 3, 4. And therefore, we are now going towards the KC expression. For writing the correct KC expression, then you give a mark. And for substituting the correct KC value of 0.016, that is another mark. And also for substituting the concentration into KC values, it means that will also get another mark. And therefore, initial number of moles of HI, going back to the table now, the initial number of moles of HI, that must be equals to the change equilibrium plus the change, then you get 0.198. It means this plus this must give you that, then you allocate that mark. Therefore, that will give you how much? That will give you the full 8 marks, right? Now, here are the notes, colleagues. If the wrong KC expression is given, then the learner can get 5 out of 8. If there is no KC expression, but it is followed by a correct substitution, therefore the learner will forfeit 1 mark for the what? 1 mark for the KC expression. Then that learner will get 7 out of 8. Then we go to option 2. In option 2, another learner decided to work on the concentration, not going towards the number of moles, change in number of moles, etc. He used the concentrations, and therefore, if that be the case, this is how we are going to allocate the marks. First mark will go to the change in concentration of H2 equals to equilibrium concentration of H2, then that will be 0.04. Change in concentration of H2 equaling to the equilibrium concentration of H2, and therefore that will give you this. I'm just not sure about these values because I can see here is talking 0.04. 0.04, but here is talking 0.04. But colleagues will verify that and then tell me. And then now Using the ratio of HI, I2 and H2 and I2, we'll also get another. Here is the ratio. Using that ratio there, the learner will also get another mark. And what is the third mark? Equilibrium concentration of I2 being equals to the change in concentration of I2. It means equilibrium concentration of I2 being equals to the change in concentration of I2. If these two are equal, then we will allocate what? Then we will allocate another mark. Then where are we going now? The correct KC expression. And this is something that we forgot to mention in the previous option, that when they write that KC expression, your formulas, your concentration, they must use the square bracket there. Formulae in square brackets there, then that will be the correct KC expression. Then that is another mark. Substitution of concentration into KC expression, substitution of 0,016 there, then that will be another mark. And the other mark will be substitution of initial concentration of what? Substitution of KC into that, substitution of KC and substitution of concentration in KC will get 1 mark. Substitution of the KC expression itself will also get 1 mark. It means substitution of KC expression itself and substitution of the concentration in KC will also get another mark, 1 mark each. And therefore, what is the other mark? Initial concentration of hydrogen iodide will now be equals to the equilibrium concentration plus the change. We are going to hydrogen iodide. If this and this gives you this, then there is another mark there. And divide 0,2 by 5 and multiply 0,396. Here we are. Divide 0,02 by 5. That is where we get that 0,004. I understand where it comes from now. Therefore, we divide here, then we get that to get that concentration there. Then if he has divided and then multiplied by what? Multiplied by 5, then you will get another mark. But colleagues, some learners, you won't see that they have divided and multiplied, but you must be looking at the correct answer there, that you have got it, what is correct there for you to be able to allocate that particular mark. And therefore now, check the range now. The range now ranges between 0,19 and 0,2. And therefore, that will give you what? That will give you the total of 8 marks for that particular question. That is question 6.2. And 6.3, how will each of the following changes affect the amount of H2 produced? Write down only increases, decreases, or remains there the same. That is 6.3.1. If we add more of I2, therefore it means we are driving the reaction backwards. And then if we drive the reaction backwards, it means hydrogen gas, concentration of hydrogen gas will do what? Will decrease. The amount of H2 will decrease, 1 mark for that decrease. 6.3.2, if you increase the pressure, therefore that will remain the same because the number of particles on the left is equal to the number of particles on the right. It remains the same. That's 1 mark, 1 mark. And then 6.4, at 325 degrees Celsius, the equilibrium constant for the reaction above is 0,014. It means there is a decrease in temperature, a decrease in Kc. Is the reaction exothermic or endothermic? Fully explained. Therefore, the reaction must be endothermic. 1 mark for endothermic. And then what is the explanation? The Kc decreases with a decrease in temperature, 1 mark. The learner must be able to indicate that there is a decrease in temperature which decreases the Kc. And therefore, because of that, the reaction that is favored is the reverse reaction, or the learner can be going towards the concentration of reactants increases or the concentration of the product decreases. and therefore decrease in temperature favors an exothermic reaction. Therefore, that will be your 4 marks there. That is question 6.4. That takes us to the end of question 6.4, and the total for that question is 16 marks. I'm not sure, colleagues, clarity seeking question or inputs. Colleagues, I might be talking alone. Alta, are you still here? Anyone, colleagues, so that I'm aware that I'm not talking alone here.
Yes, I am still here. Sorry, what's
Okay.
And my
you.
child did very well in this question, so I have no questions.
Oh, you have no question because your kids does very well.
This one, the one I'm marking.
Okay, no, thank you. Right, and then let's go to question 7, colleagues. Question 7, 2 grams of magnesium hydroxide is reacted with 30 centimeter cubed sulfuric acid solution of a concentration of 1,5 mole per cubic decimeter. According to the following balanced equation, there is a balanced equation then. And then 711, why is sulfuric acid considered a strong acid? It dissociates or it ionizes completely, 1 mark. In water, 1 mark. Therefore, a learner can get 1 out of 2 or 2 out of 2, part mark in there. 712, calculate the concentration of the final solution for 8 marks. And therefore, always, colleagues, be on the lookout for the marking criteria and put the ticks accordingly, according to the marking criteria, and then where the ticks must be put. First mark will be on the formula, either number of moles is mass over the molar mass, or concentration is number of moles over the volume. There is 1 mark there. The number of moles of magnesium hydroxide is equals to mass over the molar mass. The second mark will be when the learner substitute that 58 into this. Therefore, here is the learner substituting that 58 grams per mole into that formula of number of moles of hydrogen of magnesium hydroxide. No mark on the formula. On the answer there, 0,03448. But there is a mark on the ratio there. That from that, it means the number of moles of sulfuric acid, because they react in the ratio of 1:1. Therefore, the number of moles of sulfuric acid will be 0,03. It means up to this far, the learner has got 3 marks. And substitute is that 0,03 in the formula N is equals to C multiplied by V. It means now the learner is now, the focus is now changed towards the sulfuric acid. Therefore, he substituted that 0,03 there, then we give a mark in the formula of concentration multiplied by the volume. And therefore, calculating the number of moles the final number of moles of sulfuric acid, take note that E has got 2 marks. 0,05 initial minus final. Therefore, 2 marks there, 0,02. And therefore, F will be when the learner now calculate the concentration, the final concentration there, the whole of that substitution, 0,02 over 0,03. And then the final mark will be on 0,67 mole per cubic decimeter. That will be your 8 marks of question 712. Then question 7.2. A dilute hydrochloric acid solution has a concentration of 0,15 mole per cubic decimeter. This dilute solution reacts with a concentrated solution of sodium carbonate. And 721 define the term dilute acid. It is dilute because it contains small number of moles of acid in proportion to the volume of water. Therefore, part mark in there. Small amount of acid, 1 mark, in proportion to the volume of water, then that will be another mark. Then that will give you 2 marks. 722, calculate the pH of the hydrochloric acid. Therefore, pH is equal to negative logarithm of the concentration of the H3O plus, 1 mark for the formula, 1 mark for the substitution, and then 1 mark for the final answer. That is your 3 marks. Then question 7.3, a solution is the solution 731 is the solution of sodium carbonate, acidic or basic solution. Then 732, write down a balanced chemical equation that explains the answer to question 7.3.1. That is your hydrolysis. And they react with water hydrolysis. They form hydrogen carbonate ion. 1 mark for the reactant, 1 mark for the product for balancing. Or Elena might write that as a sodium carbonate that react with water, 1 mark, and therefore 1 mark for this, and then 1 mark for balancing. And 3.2, and then that is your 19 marks on question 7, colleagues. When Marisa Smith. Is it followed by Mr. Libenia? Marisa, can you unmute yourself? I can see your hand.
Sorry, morning.
Morning, Marisa.
I'm 1.2. The MgOH is an aqueous and H2SO4 is also aqua. And now the children ask, they wanted another volume because now there's 2 volumes that must be added together. And there's only 1 volume given volume of the solution. So what must be now?
You are talking.
They say of magnesium oxide, so that means it must have a solution. And when they wanted to calculate the final volume, that last C is in divided by V, they wanted another volume to add to the 30 to get the volume of the whole solution, because they asked the concentration of the final.
Yes, I get what you are saying.
So now the problem is that children haven't continued. They stopped there at number E and didn't continue because now they needed another volume. And they stopped there doing the calculation because there was only 1 volume given.
So the confusion that brought about the confusion is that in the formula, magnesium hydroxide is given as an aqueous.
Yes, that's the problem because the like the question, it seems as though magnesium hydroxide was a solid because of the 2 grams, but in the formula it was given as an aqua. So now they wanted another volume to add to the 30.
To the volume of the sulfuric acid.
Yes.
Okay. Can we reserve this for a while? Marisa will give a direction later on. Please.
Okay. The other problem is also the rounding calculation. Also get also 3, which is not given there because they did use there at if they use the also different the equation or just rounded the final answer, and that also gives you different answers in the range.
But now the principle is we always round the final answer.
Yeah, but that is now the problem, because when you get there where you have to times that 1.4 times the 0.03, which is 0.045. And in the memo it states 0.05. And influence calculations further on if you continue, because
You said when you multiply, when you sum to 1 in 0.0344.
yeah, if you take that ratio, yeah, and now they also have a look at 7.1
Correct.
total. Please.
Then the range there, what is the range? Is it that go below 5?
No, 3.5. Yes.
See, number is just said that answer either to one of subject advisors can engage with it.
Okay.
Thanks.
Thank you.
Mr. Lebenya.
So actually, mine was also on 7.1.2. And then who did that exactly as Memo was saying here, because the final answer is 0.355. So that will be the range from your side.
The outcome. Okay. Thank you. Can we lower hands, colleagues? If it's an old hand, Marisa. Number 8. Question 8. One function of the part labeled X. It completes the circuit, or it maintains electrical neutrality, or it provides the hub for the movement of ions for 1 mark. Which electrical type will see you? 8.3, write down the name of formula of the electrolyte in 831, the copper cell, copper sulfate, or CuSO4. Any salt that will for 1 mark. And we will accept if an has a salt that contains what 8.3.2 in the silver nitrate half cell. It is a silver nitrate AgNO3 or silver acetate or similar. Will accept if that learner writes a salt that contains the Ag plus ion, then we'll allocate 1 mark. Then 8.4, write down the balanced net overall equation for the above cell. Therefore, it will be 1 mark for the reactant Cu plus 2Ag plus, 1 mark for the product Cu plus Ag, 1 mark, and then 1 mark for the balancing. 1 mark for the reactant, 1 mark for the product, 1 mark for balancing. And no us there. And then question 8.5, calculations of the EMF of the cell. The E naught of the cell is E naught of reduction of minus E naught oxidation, or any other acceptable correct formula from the data sheet, then that learner will get 1 mark will be 2 marks is on substitution, correct substitution of 0.8 and 0.34, and then the final mark of 0.446. And that is your mark for substitution and then final mark on the answer. If a learner have used any other unconventional formula of abbreviation that is in the data sheet, then we'll basically allocate it 3 out 4. For that learner will forfeit 1 mark there. E naught of the cell is E naught read, my naught ox. Then 1 mark for the formula will not be there. Then we'll continue marking. Then that learner will get 3 out of 4. And then here, colleagues, we have got just only the options. Then 1 mark this into 1 mark will go for writing oxidation and reactor half reaction correctly. Then we will get 1 mark. For giving the correct of the cell, to give 1 mark. Each of that cell will get 1 mark, and then the last mark will be answer. 8.6 stated the standard conditions under which this cell operates. Temperature of 25 degrees Celsius or 290. The learner cannot just write temperature. It must be specific temperature of 20 degrees Celsius or 298 K, and the concentration per cubic there, and then that is 2 marks. That 8 marks on question 8, colleagues. Input. Eight is fine. Then let's go to the last question. The last question is question 9. Simplify the diagram below. Represent an electrochemical cell purification of, and the energy conversion takes place in the cell electrical to define the term electrolyte. It is called the movement of ions, which electrode contains impure copper. Write down electrode A, electrode B. Even if I only write A without electrode, then I will be credited with 1 mark. Write down the half reaction that takes place at the beam. Therefore, that is the copper 2 plus iron plus the 2 electrons. That will be copper. That will be 2 marks. And therefore, look marking criteria there. Copper 2 plus 2 electrons, the arrow, then we deduct 1 mark. It's written correctly. Just be on the lookout where the arrow is. Then the learner ready to 2 marks. This one is in. It is 0 out of 2, and as well as here we have 0 out of 2. Then on the electron, it means if that negative on an electron is omitted, then ignore, grade that full marks if everything is correct. If the charge, positive charge copper 2 plus iron is omitted, then we can give 1 out of 2. Then this is an example. The positive charge is omitted there, then we can give 1 out of 2. Everything is correct, but that positive charge is omitted, then we deduct 1 mark. Then 5, electrode A, the anode or the cathode. Electrode A will be the anode since it is connected to the positive terminal. And 6, the 2 electrodes are replaced with the carbon rods, and write down what will now be observed at 2 carbon rods. Write down what will now be observed at electrode A. What will be observed? A, it is a yellow, correct the spelling of yellow, yellow-green gas, or is a bubble gas, or a yellow-green gas will be formed. Therefore, that will be 2 marks. And then 962, the relevant half that explains the observation there. It must be this half reaction where your chloride loses the electrons to form the chlorine gas plus the 2 electrons. Then be on the lookout for the matching criteria. Because of a double arrow 1, and therefore this is not the loss of electrons, but this represents the gain of electrons 0 out of 2. This is also 0 out of 4. This is also 0 out of 2. And then here we have 2 and 9.1. As in 9.4, if the charge on an electron is omitted, 1 out of 2. If the charge on the chloride ion, not a positive charge, but a negative charge. If this negative charge is not there, then you will deduct 1 mark. And then the total for that question is 12, and the paper is 150. We just have got to take note of one outstanding communication that will be communicated later on question 1.1. Any questions, colleagues? In the absence of question, with regard to question 7.1, right? There is a hand from Matsiri.
Just general, if we can refer back to question number 2. Something with us as far as the marking criteria is concerned.
Question
2.methylene, that one. So can we please just do 3.1? It is catching up with us. Can you just go back to that one again, please?
Yes, Papa.
Okay, yes, that's the way the marking criteria is. It opens up a room for, if perhaps, like the past, you see the first mark and the second mark used to be together, and then now the second, the other mark would be for that octane, and the last mark would be for everything in order at the high. So now, if it looks like this, there are certain learners who would not start alphabetically, but everything, if we were to look only on the marking criteria, even if it is not in order. So maybe, I don't know if we want to perhaps say, we want to give 1 mark for the prefixes, and then for the suffix or the suffix, and then for everything correct.
Yeah, I get what you are saying. It means Elena might go with
methyl.
Yeah, yeah. No, I get what you are saying. That it, so I get what. Well, this is my paper, and then sometimes I'm hesitant to make a decision or a ruling. But I guess I get what you are saying. And we also communicate it.
Thank you.
Thank you. Menom Kwako.
This is Miss Brimmer, 0.4 and 8.5.
4. Yes, ma'am.
I'm going to ask my question so long. If the learner in 8.4 uses the wrong copper, from copper to copper 1+, and then they substitute that E0 value correctly in 8.5. Will we mark positive mark there or not?
So at 8.4, it does not use the half reaction of copper 2 plus. It uses the half reaction of copper plus.
Yes.
Yeah, I will say in 8.4 we'll analyze, and let's go for positive marking in 8.4.
Is made out of pure copper, normal copper. But the other two, the one that's copper 2 and the one that's copper 1, how must the learner be able to know which one to choose? Because I don't see anywhere in the question that restricts them from picking the copper plus 1, because that will influence 8.4 and 8.5, because they, if nothing stops them in the question from using copper 1 that gives pure copper at the end, the 8.4 will require no balancing, and the 8.5 will have different values.
Okay. Yeah, I had this question, and we normally use the copper 2 plus I, not the copper plus I.
I understand that that's the norm, but I mean, it's possible to build a half cell with the copper 1 plus, and it's totally acceptable in practice in real life to use that half cell. It will still be the same type of half cell. The potential difference would be a bit less. So I can't see why we can't give all the marks for someone that used the table correctly and identified a different copper. That would definitely work in real life.
Yes, Mr. Pinar, this is something that came into my mind, even myself yesterday when I saw the paper. But I consulted with the examiner and the moderator of the paper, and then the answer was we are using copper 2 plus iron, not the copper plus 1. The standard is that copper 2 plus iron is the one that is being used instead of the copper plus 1 iron. But I will also take your consent back to the examiner and the moderator of this paper again. And then the ruling will be made. All right.
Okay, because it's just because then we must teach the learners to scratch out copper 1 and never use it, or we must ask the question in such a way that stops them from using different possibilities, that restricts them to use the copper 2 plus only.
I agree with you.
All right, good. Thank you, sir.
So there will never a time when
Right. Colleagues, in the absence of